Number 2 is asking about the empirical rule. And to completely answer the question, look at page 270. And you just need to state these 3 facts: that 68% of the data lies within 1 standard deviation, 95% within 2, and that 99.7% of the data, which is practically all of it, lies within 3 standard deviations of the mean. Number 4 is asking if a normal distribution can always be used to approximate a binomial distribution. And look at page 317 for the answer. It's really nice when we can use the normal distribution to approximate the binomial distribution because it saves time and it's easier. But you need to make sure that n, the number of trials, multiplied by p, the probability of success, is greater than 5. And also n times the probability of failure, which is q, is also greater than 5. If both those values are greater than 5, then yes, you can use a normal distribution to approximate the binomial distribution. For number 10, there were 3 parts. You need to consider the distributions where n is 4, n is 16, and also when n is 100. And 305 is the page that has a lot of the information you'll need. And theorem 7.1 sums up how to answer the question. We're told in problem 10 that x is a random variable with a normal distribution. We're told the mean is 15. And the standard deviation is 3. And then we're asked about a sample mean corresponding to different sample sizes, the 4, the 16, and the 100. So you should relate these facts for the 4, the 16, and the 100. So for each of them, the sample mean distribution is going to be a normal distribution for all 3. The mean of all 3 distributions is going to be the same as the underlying mean for x, which was 15. And then the standard deviation of each of them is going to vary. It's going to be 3 divided by the square root of n, which n changed from 4 to 16 to 100. So to write that all up, the distribution of mean values for the different sample sizes have a lot in common. They'll all 3 be normal distributions, because the x was a normal distribution. They'll all 3 have the same mean of 15 because the x had the mean of 15. And then their standard deviations will vary. The larger the sample size, the smaller the standard deviation gets. So it's 3, because that was the standard deviation of the x values, and then divided by the square root of whatever n is. So 3 over 2. 2 is the square root of 4. This distribution will be 3 over 4. Because 4 is the square root of 16. And then our smallest standard deviation will be 3/10. And 10 is the square root of 100. 3 probabilities here to find in 12. Given that x is a normal variable, tells us the mean, the standard deviation. I think Excel is probably the easiest way to do that. So let's jump over there. So for the first one, if the mean is 110, the standard deviation is true. What's the chances that you'll have a number? What's the probability you'll have a number that's less than 120? So all these probabilities are already calculated for you in Excel. You just need to type them in the formula. Use normal distribution, 120 for our x, 110 is the mean, 12 is the standard deviation, and true, we put a true in there for cumulative. It finds the probability that x is any number from 120 on down all the way to 0. So there's a 79% chance, a little bit over 0.797672, that x is less than 120. For greater than 80, pretty much do the same thing. If you just use norm distribution, you type in 80 there, it's the probability that x will be less than 80. So to figure out the chances that x is greater than 80, you need to subtract that from 1. So 1 minus the chances that we're less than 80 will give us the chances we're greater than 80, which is 0.99379. And then our last one, what's the chances we're in between 108 and 117? Figure it out for 117 and for 108. And then take the 117 value, which I have here in J4, and subtract away the 108 value, and you'll get this number. And just to reiterate that last one visually with my rough sketch here, the probability that we have a value less than 117 would be all the green and all the red put together. That's every number less than 117. And if we subtract the part that's less than 108, just take that away, we'll be left with the amount, the probability that we're in between 108 and 117.